Welcome to All Things Policy, a daily podcast by the Takshashila Institution. We are a bunch of policy nerds based in Bengaluru, and we like bringing fresh perspectives to Indian affairs and Indian perspectives to global affairs. So grab a cup of coffee, sit back, and join us for today's chat.
Hi, I'm Sarthak and I welcome you to All Things Policy. In the American Civil War, two-thirds of soldier deaths were caused not by battle injuries but by typhoid, dysentery, and malaria. In other words, biological resilience is strategically as consequential as firepower. Today, a new wave of biotechnology, mRNA vaccines, biosensors, regenerative medicine, they're shaping what resilience can look like. And this innovation is coming from universities, startups, and pharma companies. The Indian Armed Forces operates across high altitude zones, tropical disease ecologies, remote border areas. How can biotechnology help in military resilience? This is a question we are exploring today. Joining me in this episode is my colleague Shambhavi. Recently, Shambhavi published a paper on biotechnology and military resilience for the Indian Public Policy Review. We will share the link of the paper along with this episode. Hi, Shambhavi. Welcome to All Things Policy.
Hey, Sarthak. Hello, everybody.
So, before we start, I have one quick question, and again, this is something which is based on my understanding of biotech and military, and mostly it is drawn from maybe Hollywood movies. So when 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 I hear biotech and military together, the picture that comes to my mind is bioweapons and some sort of super soldiers. But the paper that you have for IPPR, it argues something slightly opposite. You say that biotech's biggest military impact will be through resilience and health rather than through offense. Could you please explain this?
Sure. I should start with a disclaimer that I have zero combat experience. But I have, over the past several years now, studied the way biotech has developed and is being used in India and across various countries. Um, as you know, Sarthak, that I am an avid believer that biotechnology is the technology of the future. And all of my work on bioeconomy has come with this rider that for biotech to be used responsibly, we also have to account for the security threats that its dual use nature brings in, right? And to that extent, I've been involved in a number of conversations around biosecurity and new emerging biotech, around disarmament. May it be at the Biological Weapons Convention or the India-US Biosecurity Dialogue, etc. And whenever I've met people who, and to tell them about bioeconomy, the reaction is usually this, right? Oh my God, a super soldiers coming. I remember many years ago, one of the first people to come to Takshashila and speak about gene editing said that we are down the slippery slope of, if we gene edit for sickle cell anemia, we are not very far away from making super soldiers. And obviously, science isn't that simple. But still, the idea is very enticing, right? And so it's very easy to grab imagination. Biotechnology, on the other hand, works more sneakily, right? Whether it's part of the bioeconomy and delivering nutrition through rice that has vitamins, or whether it's at the level of the military where it can very gradually make a soldier fitter by either doing genetic changes or providing better nutrition or providing better information on the person's health, right? All of this will go in stealthily, and I think that should be the military way anyways. And I'm much more fascinated by that than by the idea of, the pathogen that is going to kill everybody or going to, topple down agriculture. Those scenarios are banned, and should remain banned. And I also find that the appeal in them is, as compared to the use of other weapons, will be lower. I hope so. But a lot of the other applications of biotechnology are not banned, and they can still be useful for military operations. And that's why the paper that don't get sucked up into this idea that biotech can only be used for, like, creating monstrous beings. Biotech can actually also be useful in small sneaky ways. But once you put them all together cumulatively, it can actually change the way a military operates.
So when you mention that biotech can help in small sneakily ways, but in your paper you have talked about how it can help it at different levels, right? It
Hmm.
can help an individual soldier. There can be benefits at the operational unit level and as well as the theater level, right? So what are the different kind of benefits or biotechnology can offer at these different levels?
Right. This is just a frame that I thought about. As I said, I have no combat experience. From looking from outside, I thought that this was a useful frame to think about categorizing the different applications of biotech that are increasingly being relevant for military operations. At the soldier level, obviously, we want our soldiers to be fitter, healthier, more responsive, be able to recover in time in case of injury or disease. We are seeing, like you mentioned, right? In India, we have soldiers who are at very high altitudes, which again requires the human body to adjust. So, a lot of these adjustments that the human body is required to make is something that we are learning more of because of advances in biotech, and which means that we can harness that knowledge to be able to help the soldiers better, right? Just in terms of, say, delivering food, nutritious food to a soldier at a high altitude level, right? So, changes in bioagriculture could enable the availability of food at when people are off to remote locations, etc. So at the soldier level, I think there's a lot that can be done, and even with current biotechnologies, um, fitter soldiers obviously will feed into better units, but units also run on operations and logistics, right? And there again, I think the use of, say, locally made biofuels is something that other scholars have also spoken about, because fuel lines are very easily targeted, and we just have a entire war on one side of us to kind of speak to that, right? That fuel lines can be easily targeted, and so the idea that you could generate fuel locally from resources available there to be able to keep your vehicles moving is great. We are technologically not there yet, maybe for biofuels, but that's the ambition to go to, right? Um, the generation of crops locally. There's a lot of things that impact supply chains that can feed into unit resilience that will be catered to by biotech. I think the most interesting part that we often kind of leave out is communication and understanding our environment. So the use of biosensors to be able to tell about a person's health, or to be able to detect toxins or pathogens or changes in your environment, and that communication. Then once you have biotech plus AI or plus robotics, that's going to be a game changer in the response times, both at the soldier and the unit level. The theater, I think, is a cumulative action of both soldier as well as unit resilience. Because the way I imagine the theater changes is that, once you have more resilient units, you might be willing to go into more remote locations which otherwise you would not have gone or could not have gone, because getting fuel there might have been impossible or things like that. But also there are extreme scenarios, like one of the things biotech is trying to do is making humans ready for space travel. And space travel is more than just having the correct rocket to go in, right? It also will eventually requires humans to adapt to space. And this has not happened yet, I think gene editing will play a role in terms of getting humans fitter for space travel, as well as again the production of food, etc. We always think space biomanufacturing as something that is attracting a lot of funding, right? So the idea that you can grow food, you can grow medicine up in space. Once you start habitizing space, space warfare might not be far away. So, and again, I think there's a role for biotech to play uh, in in that theater when it if it comes to that. I hope it doesn't, but who knows?
But one thing, so when you talk about these things, right? Let's say bio, as in use of biotech in agriculture, biofuels, or again the space dimensions. Uh, how far are these from the current time, right? So is it too far, or maybe are we looking at any of those things in the next 10-year horizon, or how is it
Yeah, I
looking?
mean, few things are already close by. Point of care diagnostics, for example, is something that is being rapidly worked on. Biofuels, obviously, India is making a lot of biofuels, not to the level that a military might require, but definitely the technology to make biofuels exists. Bioagriculture, India has more lenient regulations around genetically edited crops, so that's something that is being looked at. So I think the technology is close to being made. A lot of this is resides with civilian universities and startups, because there is a huge civilian market for these technologies, right? And maybe they have not all been made with a purpose to fit military use. But we are seeing a lot of progress in technologies. Genetically edited humans obviously are not there yet. I mean, we are now starting with edits for sickle cell anemia and thalassemia, but obviously enhancement editing is banned across several countries. I think it's only a matter of time before we start seeing the first enhanced humans. But um, yeah, even the science there is not really ready yet.
Hmm. So there is one interesting thought in your paper. So you mentioned that when it comes to many of the technologies that are right now diffused in civilian life, they were all developed by the military. Right? For instance, the radar or the jet engines, internet, they were all developed for military purposes, and now everyone uses it. Right? Internet, everyone uses it. However, you say when it comes to biotech, it is the opposite. Now, why do you say this? As in, what is the underlying reason why in biotech things are slightly different? And again, how does it impact the entire, let's say, the defense establishments?
Right. I think
Because in the internet case, right, it was meant for the military and they used it. But in this case, you are saying biotech will help in military resilience, but the developments will not happen at the defense establishments.
yeah, I just think maybe I should calibrate this a bit. Obviously, when there have been dedicated requirements, progress has happened funded through military. A classic example is DARPA, the US agency, recently had funded a program that looked at genetically edited insects to be able to deliver an antidote to a pest to orange trees in California. Okay, it's a well published paper, so this is nothing classified about this. So, whenever they have seen a dedicated problem or a technology, yes, the military has funded it. But for broader biotech, right, for a long time, we are just trying to learn from nature. So, a lot of biotechnology is trying to figure out what is happening in, say, bacteria or plants or, somewhere in nature. That's very curiosity driven. It requires a lot of money. It requires a lot of collaboration because you're heavily dependent on data sets generation and their analysis. All of this has been expedited over the past few decades because of computers and now AI, etc. So a lot of this has been accelerated now, but still, it does still require a lot of investment. And it's like an open canvas program, right? So with like the mRNA vaccine that became popular during COVID-19 had been discovered much earlier by someone who was studying bacteria. CRISPR, which is the latest gene editing technology that everybody likes, was also found in bacteria back in 1980s or 90s, I think. And then it took years and years of building onto that for someone to realize, hey, look, uh, perhaps we could use this to get rid of the sickle cell anemia trait. And so the way those discoveries have happened have not come across, there was not one person trying to say, hey, let me find out how to cure sickle cell anemia and then went and found out CRISPR, right? Because that data set is so huge, those have always been down up approaches instead of anything else. So I think that is why a lot of biotech will keep on coming from the civilian system. Also, as I said, because there's a huge civilian market for a lot of these products that will continue to put pressure on industries to make products for them. So vaccines, for example, is something that everybody needs. There might be specific vaccines that the military might require, or over time we might figure out that look, those on at high altitudes might require a different variant of a vaccine to make it more effective. That's kind of what biotechnology will teach us now, but still, the idea that everybody requires vaccines is what drives vaccine research. So I believe that this will continue to be driven by civilian, unless there are very, very specific questions like biofuels for military use, right? I think that's a very specific question which the military could fund. But for that, the military needs to think about how do we best use biotech.
Okay, and in your paper, you have a framework as well to help policymakers decide what they need to prioritize. And again, it has multiple three axes, right? One is tech readiness, another is military adaptability, another is strategic impact. Could you just uh, walk us through what does this imply, and what could be one example of a particular technology that the government needs to prioritize right now?
Yeah, so when I was making this menu of items of various applications that come from biotechnology but which might be relevant for military use, um, I thought that look, there's no point in spending like similar resources across all of these. There are some which are going to probably deliver more benefits at lesser cost. And so I tried to identify them using this framework. Whenever you classify technologies, the easiest factor is technology readiness levels. So that's the first factor I considered. But then I realized because a lot of these technologies are developed for civilian use, they might not actually be adoptable by the military immediately. So I used the TRL, the technology readiness level versus military adaptability matrix. And then obviously each application, regardless of the TRLs, will have different impact. And so then there's an impact. Again, this is all based on my estimations. This is by no ways a hard and solid truth. And I think anyone who uses the framework should use their own data and rely on their judgment to be able to place things right. I think a few things stood out for me. One is that like vaccines are a very clear uh, way for improving health, right? And the more India invests in vaccines, especially vaccines beyond the UIP program, right, in making vaccines safe for the Indian flu, instead of relying on foreign data about what the flu virus looks like. So there's stuff there that could be very useful and would definitely impact military operations. Biosensors is a very interesting area for me because it's emerging. It's not there completely yet, but would be of tremendous impact for the military if it comes through. Wound healing kind of is also interesting because trauma wounds are very, very different from civilian wounds. And so while wound healing using regenerative medicine in the civilian space is progressing, I think wound healing as applicable to the military requires a bit more attention. I think there are several different examples that I've spoken about. The one that I think falls least priority in my matrix, but it's also interesting, is waste management, especially for unit resilience, right? The ability to be able to get rid of waste. And there is a lot of work happening around the world, including in India, at looking at, say, black soldier flies to degrade organic waste into biomaterials, which is a whole different ball game. But also like plastic intake bacteria, etc., to be able to really clear off sites, that the military uses. So there's a lot of interesting things happening in biotech. I just don't think we have thought about it.
So waste management, I mean, as per your matrix, the military adaptability is quite low, right?
Yeah, because they'll have very specific conditions, right? So I can make plastic eating bacteria, or even the BSFs. They are usually tested under controlled conditions because they're supposed to be at a site in a lab or in a sewage treatment center, right? Here you're talking about, say, up in the Himalayas, the bacteria might not survive, so you might need some to make some changes for the bacteria to also survive. So that's why the adaptability might be questionable.
Okay, so it has to vary according to the circumstances.
Yeah.
So that makes it slightly difficult.
Yeah, and not everything lends itself to it, right? Because these are also living systems that you are talking about.
Yeah. So you have, I mean, your paper also identifies this. So India has a growing civilian biotech sector, and the DRDO has the biodefense labs. But the paper argues that defense biotech capacity exists but remains institutionally bounded, rather than integrated into a broader strategic
Hmm.
doctrine. Right. So what does this? What? Yeah, these are your exact words in the paper. I'm wondering what is the meaning of this, right? Institutionally bounded. Why is this the case, right? Why the capacity remains bounded, and what will it require to change this thing?
Yeah. So this is true of broader bioeconomy work, right? I always feel that biotechnology cannot be treated as a separate entity that is different from your core strategies, right? For biotech to succeed, it actually has to be embedded in all of your strategies. So, for example, if you have an energy strategy, then biofuels has to be part of it. It can't be somebody else's doing biofuels, which kind of has become what we see with defense, right? So DRDO is doing biodefense. But if you look at any of the national security strategies or any of the, statements that come out, we never hear about biotech as an important element in for military operations. The US Army has an office that looks only at biotechnology developments, right? And tries to assess which of those developments might be useful for the military, and from there picks up the projects that they want to fund, right? To increase military adaptability. So they're actually using the this is high on TRL, but let's try to make it military adaptable, right? We don't have something similar to that. And unless biotechnology become a core element in thinking about even future of warfare, right? In many discussions that are around future of warfare, how often do you actually see bio warfare as a core element? And then obviously bioweapons are prohibited, but the idea that we need to do biodefense because someone else might break the laws um, rarely seems to come through, right? And so for me, it is actually a doctrinal change that we start bringing up uh, biotechnologies. We should be discussing the idea of biodefense. We should definitely be discussing the ideas around how to incorporate biotechnology progresses better in our own military resilience as a core step of our, preparing for the future doctrine.
So one of the thing that I always, whenever the term bio comes into mind, right? Bio, health, all these risks. So again, it always raises difficult questions, I would say, around consent, privacy, uh, long-term health implications, uh, and again, there is always this risk of dual use. So how? I mean, if you are using biotechnology for military operations, we are again two risks are basically military has a very specific role to play, and again now there is some added risk, right? So how do you handle these kind of questions, right? Does India have the capacity to address some of these things? How should we go about it?
Wow. Does India have the capacity to handle? I'm sure it does. When
Institutional
Okay.
capacity, I mean, yeah.
I mean, look, a lot of these questions have been raised for civilian biotechnologies as well, right? Because they are dual use. There is a lot of questions around ethics, particularly around technologies such as gene editing, about consent of future generations, questions around are we playing God, are we tampering with nature? And I think those questions will continue to be asked. And in the civilian setup, I don't think we have properly deployed the institutional capacity to look at ethics. We do have a few ethics documents, but they don't really talk about the ethics of doing stuff. They have not tried to, I think, do extensive stakeholder discussions to try and understand what are the ethical underpinnings of Indians when it comes to gene editing. The only survey that I found was done by the Pew Research Center a few years ago, and surprisingly, India is the only country that amongst everyone that they tested, which was okay with using gene editing not only for treating diseases but also for enhancements. So it's very, yeah, we
Mm.
have clearly a very progressive country when it comes to using gene editing. When it comes to the military, though, um, like I said, right, the US already has this biotechnologies office. On their website, you can look up the programs that they're trying to look at, to increase soldier awareness, to tackle sleep deprivation, etc. These are all publicly, I mean, these are the programs that are publicly talking about. I don't know what happens in the private. There have always been speculation about China making super soldiers, which, again, technically, I don't think is possible right now. But the idea that um, China might be using or trying to find ways of making more resilient soldiers um, is not at all impossible, right? And so, when your opponent on the battlefield is going to be ready, I don't think it is the time to talk about ethics, right? We have to also be battle ready. And so, on this one ground, I'm not sure how much getting caught up in the ethics debate is going to be helpful. For broader civilian programs, yes, whether we want to do gene editing or is it tampering with God is a question we need to answer. I'll obviously fall in the let's do gene editing um, for a number of things. I'm okay with enhancements. But on the military operations front, I would say if the soldier facing an Indian soldier is more resilient because of biotechnology, I would definitely want the person protecting me to be as well.
So basically, biotechnology might not transform warfare through dramatic breakthroughs like super soldiers or science fiction, but the real impact will be through having soldiers who are more resilient. The operational units, they are better. The theaters are better. That's what I
Yeah,
would assume is the
yeah,
conclusion.
yeah. I mean, look, everyone's like, oh, drones. Drones are so fancy. Oh, drones. But you know what? There's a human being that controls the drone at the end. And you know what biotech does? It can actually help the human brain directly contact the drone, right? And it brings down that even that reaction time that that is wasted as the human being communicates its decisions to the computer, right? And I think that's where warfare will eventually go to, right? Who can respond quicker? And so, yeah, it's not going to be fancy. It's still going to be the drone hitting, but the real advantage is going to be who will respond faster, and that is going to lie in biotech.
Okay. Thank you, Shambhavi, for this detailed overview of how biotech is going to shape military resilience over time. Thanks to the audience for tuning in. And the link for the paper is along with this episode. And also to our listeners who write paper, who want to submit their paper to IPPR, you are more than welcome. The IPPR website has the details how you can submit your papers. Thank you.
Thank you.
If you liked our show, dive into Taksashila's research on technology, strategy, and economic affairs. Check us out at our Twitter handle @TakshashilaINST or our website takshashila.org.in.